So this is a fall 2015 exam question, and it's indeterminate torque. So indeterminate torque. And I know that it's indeterminate because I have a given torque of 680, and I have two shafts which have different lengths, different materials, different radius. So I don't know necessarily what my torque at A and my torque at C, I don't know how that's going to be distributed. This is a lot like the practice one you guys had yesterday, where I had a core and then I had an outer sleeve. And I know that the applied torque was some amount, and I needed to know how much material or how much torque material A and material B carried. So statics would have started T equals TA plus TB, and then I would have known that phi at the end from material A had to equal that phi of material B. Okay, it's the same concept. You always start here. When you see that you have more than one unknown, it tells you that you have to move into indeterminate. Now this one is worded a little bit differently because we want to go back and find what the diameter of B to C is. And so we're just going to go ahead and write down all of our givens. G is 39 gigapascals. You need to remember that that is 39 times 10 to the 9th pascals, which is 39 times 10 to the 9th Newton per meter squared. You've got to keep up with your units. G here is 75 gigapascals, which is 75 times 10 to the 9th pascals, which is 75 times 10 to the 9th Newton per meter squared. I'm also given a diameter, okay, right here of 30 millimeters. The first thing you need to remember is this is a diameter, and all of our J equations are in terms of a radius. Remember, C equals radius. So I'm going to make that a radius of 15 millimeters, and then I'm going to go ahead and convert that into meters. I need everything in this problem to be in a Newton meter units. Okay. So if this were I was already given the diameter, and given the diameter, I would be having to find these torques. When I found these torques, I could go back then, when I find that torque at C, and I could go back and find the shear stress, TC over J, okay? So if I wanted the shear stress, I have to go from finding the torque to then finding the shear stress. I could also then actually answer, what is that angle of twist? Okay, but this one, it says I want to determine the required diameter of this brass portion so that the reactions at the walls are the same. Okay, so I'm going to start with equilibrium. And when I start with equilibrium, traditionally, I'm going to draw a free body diagram, and I'm going to know that I have torques at these walls, which is then the torque that's internal, and that the sum of torque of BC plus torque of AB equals 680. That would be my two unknowns. However, the problem statement tells me I want them to be the same. So if they are the same, then I know the torque at both of these walls is 340 Newton meters. Okay, and I'm trying to solve for the diameter of this part of the shaft. And so I know what the torques at the walls are, and now I can go back and I can say that this angle of twist that both of these are twisting has to be the same. So that's my compatibility, that the phi of C to B and the phi from A to B have to be equal. And this time I know the torques. I'm trying to go back and solve for the diameter. Okay, you need to be comfortable working these problems where you're given different information and be able to work forwards and backwards. So I'm going to have the torque of C to B, the length of C to B, the J of C to B, and the G of C to B equals the torque of AB, length of AB, J of AB, G of AB. And I know the torque because we were told they need to be the same. And I know the length, 1.6. I know the torque, 340 Newton meters. I know the length, 0.75. Okay. J. J is a function of the radius, pi over 2.015 meters squared. And then G was given as 75 times 10 to the 9th Newton per meter squared. So I have everything in newtons and meters. I know everything on this side. I'm going to have to go back over here. And J, I'm trying to define the diameter of C to B that makes the torques at the walls the same. Pi over 2 C to the 4th. Okay, that C is the radius. Once I find that radius, I can go back and find the diameter. So let's go ahead and get started. So I'm going to have 340 Newton meters times 1.6 meters divided by pi over 2 C to the 4th. And then my G is 39 times 10 to the 9th Newton per meter squared equals 340 Newton meters times 0.75 meters over pi over 2.015 squared, 75 times 10 to the 9th, okay? And then I can back calculate here for C. So C equals 0.042698 meters. And remember, that's our radius. So we need to multiply it by 2 to get diameter. And we're also going to change this back to millimeters. 1, 2, 3, 4. Nope, 1, 2, 3, sorry, 3. We're going to change this to millimeters, because who's going to go in and order something at the parts store with a meter for my diameter? So I'm going to get that my diameter equals 85.4 millimeters. Okay, again with this problem, let's just kind of go back through it. We can look at it and know that it's indeterminate because we have these two unknowns. In this problem, we want these two unknowns to be equal, which means they have to be half of what's given. And we were asked to go back and find that diameter. Okay, this is exactly like the problem that you guys had on the quiz, where we had two materials and we didn't know how much torque was being carried by each material. In this case, I wanted to know what diameter I needed to make this so that both of the walls had the same torque at the walls. A lot of times you're going to be given the diameter and you're going to be asked what is the torque at the walls. And so you would have equation 1, torque plus torque equals 680. And then you would have equation 2. Your radius would be given and you would be solving for TAB and TCB, 2 equations and 2 unknowns. On the exam, make sure that you are paying attention to your units, okay? What if the question then went on and said, what is the shear stress in C to B? Well, that's just going to be the torque C to B, C over J, okay? What if it asked for angle of twist? Torque C to B, length over JG. So then you could go on and answer both shear stress and phi, okay? Once you get the torque at the wall, then I could cut it internally, find that internal torque, and then continue on with shear stress and phi. Okay, your first step, though, is always going to have to be finding that torque at the wall. If you guys have questions, please see the TAs today.